Welcome to the project demonstration of line to neutral fault identification through IoT along with buzzer and LCD visual alerts by using PIC microcontroller. So here we are going to find the line to neutral fault in three-phase power supply section. So those are created by manually in real time. These are going to be identified by the microcontroller directly with help of the resistors and the potential transformers. In real time we are going to use a potential transformer in order to check the power supply availability in the particular phase. If is there any line to neutral fault occurred, then automatically the power supply will be isolated and that will be identified by our PIC 16F73 microcontroller, and those are sensing connection pins are interfaced to the A0, A1, A2 pins. And next, whenever we get the fault alerts from the switches detected, then we are going to give the audible alerts through the buzzer. So the buzzer is connected at C3 pin of our microcontroller, and also we are going to send the same data through the Wi-Fi about the status normal or is there any abnormal, nothing but line to neutral, nothing but R2N or Y2N or B2N fault. So this will be sent through this Wi-Fi module as ESP8266 and to the mobile phone, and also we are going to send the details on this LCD, that's 16:2 LCD. We are making use of that. So here ESP8266 module interfaced at B0 and B1, and LCD is interfaced at B2 to B7. And from here we are going to provide the 5 volts regulated power supply directly to this motherboard. So here we are going to provide the 230 volts to this adapter, and after that we will get the 5 volts constant DC voltage that was given as main power supply input to our motherboard. So in this the motherboard will take the input from these buttons and control the outputs. And here one more capacitor is there in order to maintain the maximum current while executing the steps, means while sending the data to the Wi-Fi module. And here making use of one more crystal oscillator, that is 20 megahertz of crystal oscillator, the steel coated one. And this one is a reset switch in order to restart the microcontroller. And red color is a power LED indication, and a green color is program LED indication. It will blink for every loop continuously execution. So before switching on these kits, we need to do some initial steps. So make a note from here very clearly, so that we need to install the applications. One is Juice SSH. If you are using advanced normally above 8 version of Android, so then Juice SSH directly available in the Play Store, or else you can go with the another application of SSH clients and follow the same steps. And Juice SSH and one more network analyzer. These two are very important to be installed in your project. And the next, go to hotspot settings and switch on the hotspot. Okay, and enable the hotspot. So the hotspot name should be project 4587. All are small letters without any space. I'm repeating that. All are small letters without any space. And the password is 129 clearly. So check 2 to 3 times before switching on the hotspot, and after switching on the hotspot, just switch on the power supply to our main controller. So once the controller get the power supply, there will be a welcome message on your LCD screen, and the status will be displayed if it is normal or normal status. So you can the buzzer is on and off 2 times. You can check that one device is connected, and after this go to the network analyzer app. In order to go to LAN scan and do the scan. There we will get our IP address of our ESP module as a kit module. So ESP Express incorporation, that is 192.168.182.195. Note on that. And now go to Choose SSH, and here manage connections. So just I'm removing that older one. So just I'm showing so add, and here type telnet. First step. Second step is 192.168.182.195. Right. So this is the second step. And third step is port number 8080. That's it. Okay. These 3 are very important. Repeating that, these 3 are very important. And now okay, and now make a connection to that. Then there will be a message of these 3 lines, and then status is normal now, and also LCD status is normal. Whenever the R2 neutral fault is detected, So we can get that auto neutral fault. The same status will be displayed on the LCD screen also. If it is normal again, normal. Same Y to N. Okay, same Y to N will be sending to the mobile phone. And next B to N. So here the switch connections are like, so this switch is given for the phase and a neutral. So whenever we join this switch, so the particular two pins are attached and the microcontroller will get the 0 voltage. That's indicated as line to neutral, and respective pin numbers, nothing but A0 is for R, A1 is for Y, and A2 is for B. So in this manner we are going to identify the which phase is fault with line to neutral fault. Okay, so same thing. Okay, you can observe the same appearing on the mobile phone also and LCD along with buzzer indication. Right, thank you.